Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz. As always, my name has yet to change, and I'm your host. And today is all about sending mixed signals to zombies because we're going to teach them how to chase us, and then we're going to run away. It's going to be good fun. Before we get too into that, let me remind everyone that this is, of course, the Flutter community. Oh, I don't even want to be wearing these headphones. Sitting in a room by myself, listening to nothing. This is the Flutter community. So let's bring forth kindness to each other first and foremost. I think I'm ready. So yeah, today we're going to be continuing the zombie shooter, the infinite zombie shooter, yet untitled, I believe. Maybe we'll call it Untitled Zombie Shooter. That I've been working on over the course of 3 previous episodes. And to begin, let's recap what this game does. So let me go here and bring up the game. There we are. So we got this map. It's very exciting. There's one zombie on the screen you can see, and we have a player that moves around, and there's some unwalkable terrain. That was the source of that was the content of the last episode. So I cannot walk into this house. Maybe one day, the door would be functional or something. You also can't just walk straight through a tree. You got to walk around the tree or in front of the tree, but you can't. Oh, I appear to have not put a hitbox on this one. Oh, no, I guess I did. Oh, yeah. Okay. There is a hitbox on this tree. But yeah, so we've got this is our situation. Not everything that should have a hitbox has one yet, but I don't think this castle has one. But the having some unwalkable terrain is enough to think about pathfinding for our zombie, and that is what we're going to work on today, getting this zombie following me along or following me around the map, and then we're going to run away from it. So let's begin. I did a little bit of work off stream to help visualize the pathfinding here, because typically in pathfinding, in general, that's kind of a solved problem, right? There's Dijkstra's algorithm, there's A star, and those help you traverse through a graph of nodes based on the travel weight from one node to the next. And they find the optimal route. But in a game like this, it's not really clear what the nodes would be. I mean, you could just kind of decide on some minimum granularity. Maybe that would work. The smallest possible minimum granularity would be a single pixel. That would be a lot of nodes. That would be totally bananas. So maybe it's like 4x4 pixel grids. Maybe it's 3 by different. You could pick different sizes, right? And decide, okay, that's a node in the graph. Another thing you could do is just maybe make every corner of an unwalkable object a node. I've been thinking about that over the last few weeks, and that's kind of the direction that I want to go in. But zombies are also dumb, and zombies can't work their way out of a maze. They get caught on simple obstacles. Part of, I think, this whole game, once there's actually the ability to, fight the zombies, will be kind of getting them caught in dumb situations, right? Kind of walking them into like U-shaped areas and then being on the other side, and them knowing how to follow you into the U shape because they're just kind of tracking your direction, but not knowing how to then backtrack and go around. And that's what Dijkstra's and A star do, is they implement a really strong, complete pathfinding. If there's any way, no matter how complicated the maze is, if there's any path between the source and the target, the pathfinding algorithm will find it. But that's not how zombies behave. So I want to kind of work on like a fuzzier algorithm that is simpler and less smart. And that is what we're gonna do today. Um, Good to see you all in the chat. Thanks for joining. We were not able to advertise this episode in advance like normal. So all of you who are here, I appreciate you. Okay. Let me walk you through some of the work that I did off stream to help visualize this pathfinding adventure. So the first class that I wrote is just a line. And so it has a start and an end, and they're just vector twos. And it has a couple helpers, things that lines have, like slope getter, a dx dy getter. It can figure out its center point. It has it can calculate its length and its angle, blah, 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 a couple things that lines need. There's this pretty interesting function down here that I have yet to use, other than I wrote a unit test or two for it, but I'm pretty excited for this. It's the intersects at, and this method detects whether or not this line intersects a different line, and it returns the point where they intersect if they do, or it returns null if they don't. And I just Googled this code and I have no idea what it does, and I never want to know what it does. I actually took me a minute to find this solution. Eventually, someone posted something in C on Stack Overflow, and I just translated it into Dart. But so many answers were like, this is the proof for figuring out how one line intersects another one, and like walking you through trying to understand the algorithm for it. And I was like, that isn't what I want. And I eventually found someone that was just like, here's the answer. And they posted it in C, and then I just ported it to Dart. So this is we're gonna be using this later. Okay, so this is the line class. Pretty simple. Next, there's a line component. We need to be able to visualize where things are going, where things would be, what are the boundaries around unwalkable terrain, all kind of stuff like that. So this line component takes a line, which is below the constructors somewhere. Oh, and I've got some convenience constructors to draw the line in different colors. And anyway, it takes a line and a color, and then it's eventually going to draw. It's going to use a rectangle component that's from Flame to actually draw the line underneath. And this component took me, honestly, quite a while to get right. And the trick was just getting this child object set correctly. There were a couple details that were really, really tricky. First of all, I needed to realize the right angle to provide to the rectangle component. And then I moved it over to the line itself. And then the last thing that I had to do, I was trying to position this child component on the line component itself, and like handle the appropriate, handle positioning it correctly based on that, like translate from the line's own component start parameter against the line component's position, which I think it has somewhere. Anyway, that was actually, I don't see a position. Maybe I got rid of it after I stopped using it. That was a real nightmare. But once I added it to the game world itself directly, in conjunction with having the correct angle, then it worked. And then there's a little debug mode. You can draw a colored square on the start, middle, or end. I was using that a lot when I was developing this component. And lastly is the colored square. And I'm going to add all of these. Colored square, again, just uses a rectangle component and paints a little color. All right, I'm going to check chat here before I add all of these files to the code base and get into it. Ken says, let's face it, a zombie would probably just walk straight towards you until blocked, then get stuck there. Zombies against fences rings a bell. Yeah, exactly. So they don't need they don't need to be that smart. I was thinking they could be a tiny bit smarter than that. Um, and if we go back to the game, so what I was imagining is right now the zombie would say, I'm here. Also, probably some max distance beyond which they don't do anything. So if you're within, they all have like some kind of sensory radar. They'll only follow you if you're in that radar. But let's say this is close enough. And so the zombie knows, all right, I'm here, you're there, and I'm going to track you directly. So it would go straight to this wall and then it would get stuck. And it's like, well, would it get stuck or would it just kind of move down the wall and keep going? And I think, there's a lot of different ways we could do that. It could just lose the Y portion of its vector, its movement vector. So it moves up against the wall, and then you can kind of imagine it's just like dragging its face against the wall, but it maintains the X portion of its vector and it slowly slides down the wall until it can eventually keep going. That's an interesting idea. But it might get stuck at the very end, or it start kind of have a little Zeno's paradox where it's getting to the end, and so almost all of its vector is Y, which is lost, and its X vector is approaching 0 until it, does. Would it ever actually get to the end? I'm not really sure. But the other thing that I was thinking is that a zombie could say, all right, my path to you crosses some unpassable terrain, some unwalkable terrain. Let's instead find the corner of the unwalkable terrain that is not, what's the word I'm looking for here? The corner of the unwalkable terrain closest to the target, and then just go to that instead. So we'd say, all right, we're passing this wall here, this boundary of the unwalkable terrain. And so we could run a quick thing to be like, what are the corners of the unwalkable terrain? Oh, it's like over here somewhere. And have the zombie just track that instead. And then it'll be able to do a little bit. It still wouldn't be able to get out of a maze or potentially even a U shape. But we'll have to build it and test. Billaboy says, they can hit the fence and then take the shortest path to the player. I presume you're talking about possible game logic here as opposed to behavior that you have personally seen out of zombies. Can add smartness after, it doesn't have to be perfect. That's definitely correct. All right, let's do it. So I'm going to add these files. They're not even saved right now. They're just in this folder from my desktop called Observable Flutter Research. So I'm going to copy this and add it to another file and save it in the real thing. Dev git Craig zombies lib utilities. You can see that's where I developed it originally. So this will go in line.dart. And that's looking good. In line.dart, yeah, you're going to need equatable and all that stuff. Okay, let's save line component. Oh, I'm going to have to copy it into a new file, save it. All right, line component. Oh my gosh, I'm going to have to do this every time. What a nightmare. What a terrible situation. Zombies, lib. Yeah, components for this one, right? Literally has component in the name. Feels like a gimme. All right, and the colored square. One more time. Git. One thing I like to do, by the way, I have this Git folder. Every repo is in here. These are all of the organizations or users on GitHub, and then all of their individual repositories that I have checked out on my machine are nested under that folder, and that makes my local file system structure mirror GitHub's, and it's just easier for my simple brain. Okay, this is colored box.dart. Okay, and now I need to add equatable dependency, equatable, save. See how else we're doing here. Oh, Ken with a good question. Do you have any states for zombies such as sleep, wander, follow? Yeah, that's so good. Yeah. I hadn't thought about wander. I had definitely thought about like sleep and follow. If you get out of their range and they do nothing, well, they don't follow anymore, but wandering would be really good. That's a great thought. All right. I need to, let's make sure that those files run. Somebody's unhappy about something. Oh yeah, I don't have a barrel file in that utilities folder. Lib utilities utilities.dart. And this is going to export line.dart. I don't remember what else I had here. All right, so you should know about a line now. What's the problem here? Utilities, line. Oh, there's constants file. Is this not being used? Is that what this is telling us? No, it's being used. Oh, I think it doesn't like the relative import or something. Okay, vector math. Do I not have that one? I think we had that transitively from Flame. Vector math. Vector match. Oh, that's like a dating site for mathematicians. Vector match. Okay, looking good. Do we not have that? Oh, I don't have it. I think I got rid of it. Okay, so radians to degrees. What's this again? Do I need to import math for this? No, we don't need to import math. I'm just going to Google radians degrees to radians is, oh no, I wanted to go the other way. Radians to degrees, it's like 57 something. Yeah. All right, so let's say const double radians to degrees equals 57.2958 according to Google. Okay, looking good. Oh, radians to degrees is exported by vector math already as radians to degrees. Wonderful. Radians. Get out of here. Probably less precise thing. Thank you, Wolfen. Welcome. What else is wrong? Why do you not know line? Line. Okay, the name line is defined in. Oh, I had an early version of line in this file that I can now get rid of. Yeah, we were working on this a long time ago. Be gone. Okay. Undefined colored square. So you need to bring in components, but actually components needs to export colored square. Colored square. Colored box. Okay. Line isn't a type, which means it needs to be imported. Utilities. Utilities. Hey. All right. And now we're not getting radians to degrees from vector math. Oh, yeah. This so line was mad at me because I'm using equatable and not everything is final, but I wanted to cache an internal field. Oh yeah, I think it was slope. I don't know, something. I wanted to be able to no, I'm not caching slope. I'm caching something somewhere. Oh yeah, the vector of the line. And I just didn't want to calculate that every time. So, and the length. Yeah, there it is. So it's equatable, but not immutable technically. And what are you going to do? All right. Let's rebuild the app, make sure the game still runs, and then it will be time to make the zombie do something. It is building. How's everyone doing today? We got our game. The zombie has an obstruction blocking the direct path between it and its next meal, between it and lunch. So here we go. One of the first things I wanted to do was in the zombie component file, let's add a line for let's add a child component that's aligned to the player, and we can visualize this. Oh, let's also add lines for all the unwalkable terrain. So that's in the world. So in the world, this probably should happen somewhere other than in the ever-growing onload function. But for now, taking the map file out of tiled and iterating through the types of data objects in that file that imply unwalkable terrain, as indicated by the blocks movement flag that we set in tiled. And, here we're just looping over the XY coordinates that we get for everything. And these XY coordinates are in the raw pixel coordinates of tiled. So we are applying the world scale value because everything in the game is just 4 times the size of the actual pixel value. So we're grabbing on to every point and adding all these vertices to a polygon that we're building here. This list of vertices. And then in the end, we add this unwalkable component. And actually, the unwalkable component is what should really add its own lines. But for now, I'm just going to put them here real quick. So we have our line component, and I guess we want to save the first point, and then when we get to the end, we'll add a line for the last to the first. But other than that, we'll just add lines as we go. One of the rules for tiled unwalkable terrain, or no, it's actually, I think it came from Flame. If you're adding like a polygon, you needed to add the points of the polygon in, I think it was counterclockwise order. Whatever you had to do, I did in tiled. So they're not going to randomly crisscross and whatnot. All right, let's add these line components and just see this draw. So here is where, unwalkable component edges. We're already grabbing every, oh, nice. Just storing all the lines here. I don't remember doing that. It's really convenient. So let's visualize those. So for final line in unwalkable component edges, now we can say add a new line component, and let's call them red because you can't walk through them. And we are not able to import this. What's going on? Components. Oh, I didn't add line component. You have to squint to sort something alphabetically. I don't know if you knew this. Okay, now I know where to put it. Line component dot red, and you need a line, presumably. That might be good. Oh, I can give it a thickness as well. Let's make it thick. Rebuild. What's it gonna do? Crash. Wonderful. Debug does not equal null is not true. That is a huge failure in constructor design. Debug does not equal null. Yeah. I don't know why I didn't make these default to false. Mm-hmm. All right, here we go. Oh, these line components all have their own debug. They're all getting their own position. drawn from the global debug mode coming from Flame. Wolfen, is it possible to turn that off for a specific component? That would really be wonderful. Oh, it's in the game. That would be wonderful. Okay, we can now see our unwalkable terrain, and we'll be able to visualize, we'll understand why we can't go somewhere. And we can partially go into it. Oh no. Oh, this is interesting. See, I can walk here. I can kind of get down to this spot, but it's possible to like enter. Yeah, my collision detection logic is actually just imperfect, and you can kind of sometimes partially enter them. But anyway, we can see what's going on there. Oh, you can override the render debug method. Okay. So in line component, we will override render debug and not do anything. And we just return. Doesn't override an inherited method. Oh, it's going to be on the child. Because I'm for the line component, what am I even using? Oh yeah, custom painter. I don't even think I'm using the custom painter anymore. That was a really early version of this. That's super funny. Yeah, there's no painting going on. So I'd have to do this on the child component itself. So I'd have to actually subclass it, which I just don't want to do at this time. But I guess I will briefly. I don't know. Yeah, let's do it real quick. Let's do it. So let's say class line rect component extends rectangle component. That was some interesting syntax. So I need to know, I'm passing these parameters. So we'll say line rect component, and it's going to be super.size, super.angle, super duper, super.position. All right. And now we get rid of all these. No associated positional. Oh, gotta have the curlies. And let's make all these required because that is what I was doing. What are you upset about? Isn't referenced. Yeah, I'm working on it. Okay, now we can override the render debug. And we'll just, is it still doing nothing? Render debug mode. Okay, I think I still had to do it on this. Isn't a valid override. Okay, so it takes a function. Is that right? Canvas function. So like this. There we go. And we're just, now what are you mad about? Oh, I still don't have it right. Render debug mode. What is the signature of this? Takes a canvas. What did I type? I thought that's what I typed. Oh, just takes a canvas. Oh, I misread it. There we go. Anyway, return. Oh, I didn't have to add a child class. Oh, would that have so if I had added it to the parent class, would it have short-circuited recursing through the tree? Is that right, Wolfen? Is that why I didn't necessarily have to do that? If so, then yes, he says. All right. Well, we learned something all the same. Let's get rid of a lot of this stuff. And in the debug mode is back on. So let's see here. Oh, So I still have, I have, I have to do it on the higher component as well. So the override was really pointless, super duper pointless, because it didn't even grab the higher one. So this is just going to go back to a rectangle component. And then this can all go away. And we'll refresh. And there's still a bunch of debug stuff. So I'm going to do it on both. And now let's see what we get. All right, there it is. Either I did it wrong or we had to do it on both, but that's okay. So we've got our debug on just our characters. Now let's add that line from the zombie to the player. That's the whole point. So this is going to be on update or just update. Override void update. And of course it takes the double of the DT, the delta time. But what we're going to do is get fancy. Let's create a line component and we're going to add it to the world. So we can say, we have the game ref on this zombie. So we can say game.world.add, and then we're going to add this child component, which will be a line. Oh, we might need to make, well, let's first get the line from us to them. So final path to player equals a line we may need to import from utilities. And the start of the line is our position. And the end of the line is the game.world.player.position. So we have the path to the player. Hey, not TIL, Wolfen, TWL. Today, we learned. We have the path to the player, and let's add a line component. I'm thinking about what we're going to need to do for every frame when the player moves. So I think we're going to have a line component that's like nullable maybe, and we say path, something like that. Add this component. So now we'll say if, what was it? What do we call it? Path. That's a terrible path to player. Goodness, what a terrible variable name. Oh, well, now okay, this is line to player. Visualized path to player. So if the visualized path to player equals null, then the visualized path to player is a line component. And let's make it blue, I guess. And the line is going to be the actual path to player. And what's the problem here? Oh, yeah, we could do that. Okay. So that was a little shortcut. All of this, I mean, it's not too exciting. The linter tells you exactly what to do. All of this is equivalent to this. So we'll do that. And then, but the other thing is, we have to update the line when the player moves. And the line component is prepared to have its line updated. In its own update method, it just starts from scratch on the line. So whatever, we'll just say dot line equals path to player. Oh, because the receiver can be null. So silly. Let's see if this works. It crashes. Very good. Thickness does not equal null. Who wrote this code? it's like, can you have some default thickness? What are we even talking about here? They say if you want something done right, you got to do it yourself. But that doesn't really apply to me. Not seeing the blue line. Oh, I didn't add it. Oh, that I really do. We're going to go back to the old thing. I remember now why I wanted to do it the other way. So we're going to set it, and then we'll add it. And else, we'll just update the line. This is way better. All right, now we've got the line, and look, we can see where the zombie wants to walk. Folks, this was some serious Saturday morning development time to get this right. I even asked the Flame core dev team if something like this existed. They didn't have anything for me. So here we are. Now we can use the intersection thing to do some more stuff. So let's figure out, actually, let's first have the zombie just walk on this line. How about that? That'd be interesting. So the zombie's going to need some speed. So let's give the zombie some speed. This dot speed equals, what is the player speed? I don't remember. The player speed is world tiled size times 4. So let's give the zombie speed a default of world tile size times 3. I think you got to be able to outrun the zombies. And then so the speed is double. Or double. All right, so now in the update method, the zombie can move. Also, let's put this whole visualization thing in like a debug pathfinding method. Because we don't want a really long update method. All right, now let's have a move along path. Oh, so the path to the player should move up top. And then we'll pass in path to the player here, I guess. Okay, so we have our path to the player. So let's move along path. Which takes the line. Path to player. Okay. My favorite question. This VS Code theme is Synthwave 84. It's really nice, isn't it? Oh, Smash highlights. You didn't know about the thing. Yeah, well, it's a nice little shortcut, but it doesn't always work because if you're going to do anything more in that if statement block, then it doesn't suffice anymore. Murph says, my brain perceives the code that appears as red in the theme you are using. Oh, interesting. It's purple and pink. Well, there is some red. This is red, but most of it is purple and pink. All right, so we're going to move along the path, and the first implementation of this is going to walk right through the unwalkable terrain because there's nothing preventing that from happening. So we'll revisit how the player doesn't walk through the unwalkable terrain in a bit. But to start, we'll just say position plus equals. Actually, I'm going to revisit what I did in the player. Oh yeah, so movement, this frame, we need a movement vector times the speed times delta time. Stealing. So movement this frame, the movement vector, so let's say final movement. And I think this should be the path to player dot normalize. Oh, dot vector 2, which was a getter on that. And then here we'll say dot normalize because we want it to be of length 1. So this, why are you a move? Why is movement a double? Normalized. I want you to be a vector 2. There we go. Randall says, I believe that one operator that I don't actually know the name of isn't working is because of the inability to non-null promote a class property. If you'd done it with an if case, you could get that to promote as a local variable. So it was working. The problem was that I wanted to do more stuff in the condition where it was null. It was working. But there is certainly non-nullable property down here. The non-nullable property stuff was kicking in 100%. Oh, Lucas. Yeah. So normalize changes the mutable vector 2 that you're using it on. And so does it return? What does it return? Why would it return a double? Does it return the old length? Because the new length is 1. I don't need to know that. I don't need that returned. It's an interesting method. Billy Boy says, does the player have a gun? Bullets would go in a straight line and hitting the zombie would put it into a sleep state or reduce its life. I don't know if you've given life to the zombies. Yeah, well, giving life to zombies is hard. They've already squandered their first life by allowing another zombie to bite them, which is really embarrassing. But they are going to have some kind of life, and the player is definitely going to have some kind of way to combat them. I was thinking about making something fun in Rive. I've been talking to the folks at Rive. We might have an episode with them soon where we make some kind of effect that maybe like a fireball or something. And we shoot it at them and it'll explode and it'll look pretty cool. So let's revisit what we've got here. There's a path to the player. This is of unknown length. So we grab the vector 2 out of that line, normalize it so that the zombie moves at a constant rate. I don't yet know if this is going to be appropriate. We may need a multiplier higher or lower on this to make sure, because this movement vector is, oh no, the player's movement vector is probably normalized as well. Oh, it's actually not. The player's movement vector is normalized if they're only going up or down, but if they're going diagonally, then they're moving at a little faster than 1. Maybe we'll leave that in the game. Maybe we will. We'll see. But anyway, so this will be similar. So that's good. Then they have their own speed, which is just a little slower than the player. We've defaulted. Maybe there'll be fast zombies. Maybe there'll be even slower zombies. But the average zombie is going to be a little slower than the player. Times the delta time. And then it's just position plus equal, or we just add movement this frame. Let's see. Oh, Lucas has more to tell us. Normalize always returns 1. Oh, except for the 0 vector when it returns 0, since you can't normalize the 0 vector. Nice. So you just find out whether or not it was a 0 vector. If you even bother to check the return value, which you're probably not going to. All right, so the zombie is in theory going to move along this path. It is moving the wrong direction. Nice. So this, I think, means the vector 2 on the line class points the wrong way. Vector 2. Start x minus end x. Yeah, that's wrong. It needs to be end x minus start x and end y minus start y. Nice. Oh, it's still going the wrong way. What on earth? All right, now I'm just confused. End x minus start x, end y minus start y. This isn't like cached, is it? Someone asked in chat what the name of this is. Muir. I don't know. I don't know what it's called. That's a good question. Someone ask Bard or ChatGPT. Why is it moving the wrong way? This isn't printing. Now it's printing. All right. I'm pausing this to look at it. We have a positive x value and a positive y value, and they should both be negative. The zombie for the line does add. Where did the path to player get created? Oh, right there. Yeah. We start in our position, right? Start in the line. Oh, was I? Can you believe it? It opened the old line file. Gosh, that could have taken so long if I didn't notice that there were two line files open up here. Very silly. I do not approve. All right, that should work. The null aware assignment operator. Well, now that you say that, it feels a little more obvious. Okay, the line doesn't update correctly if the zombie moves. It was only updating correctly when the player moves. That's super interesting. We can see it's still the correct line. It just has this fixed starting point. Oh, is that because... No, I don't know why that is. That's interesting. This is kind of fun. We are getting away from it, though. This feels like the zombies are way too fast as well. I think we're going to need... The player is going to need a lot more forgiving zombies than this. So let's slow the zombies down. Stop printing that. Slow the zombies down, maybe half speed. And what is next? I do kind of want this line to update correctly because this is going to help us visualize when it adjusts, when a zombie adjusts its path around some unwalkable terrain. So in its update method, oh, this is the line class, not the line component. So in the line component, in the update method, so let's look at this. On load, this is the size, yeah, okay, of the line rect component, blah, blah, blah. This part all seems fine. So then in update, the child dot size, the position of it isn't changing. That's what's interesting. It's the position of anchor. We're going to need to do this again. Where did anchor come from? What are you? That's the position of our own anchor. Oh, interesting. What is our anchor? This didn't even have like a anchor is center. Position is line dot start. So we need to say in the update method that our own position equals line dot start, and our own, I wonder if that's sufficient, because the anchor is going to stay the same. Oh, and then, no, I think there was one other thing. the position of, yeah, we're going to have to do this as well in update. So this is the child.position equals the position of the anchor. All right, that should do it. Let's see. Back to the game. All right, there we go. Now we're being tracked in a really creepy way. All right, so the zombie can just walk across immovable terrain because it's a cheater. So let's fix that. And I kind of want to have something smarter than just, I don't want to copy and paste all this code out of the player. That's obviously really terrible. So let's think about something better. So how does the player get stopped from doing this? Well, let's revisit some logic from an amount of episodes ago. I don't remember how many it was. Probably the last one. So in every frame, actually whether or not the player is moving, we haven't even checked that yet. We're going to grab the original position and figure out the movement speed this frame. Right, we could say if movement is none, then just short circuit, but grab the original position, just hold on to that for later. Then we figure out how far the player has moved this frame, and we save their actual position. This is different than the copy that we're holding on to. Then we check for collisions with, what's the word that I'm looking for? We check with collisions with unwalkable terrain. So we look at the top center, and this is where we're getting that really imprecise. Sometimes the player can walk in the house partially, sometimes they can't. But they walk. We look at the top center of the player if they're moving up, and query the game world for components at that location. If we find an unwalkable component at that spot, then we take the movement this frame value and we zero it out. For Y, so they're not moving up anymore. Then we do the same thing if they're moving down. We check the bottom center, and that's a position. So then we query the game world for all the components at that spot. If any are unwalkable, we zero it out so they're not walking down anymore. Do the same for left, same for right. Then basically ignore the position right that we did up top, which means that was interesting. Oh, I think I had to do that for the position of anchor code. That's right. So we update the position here. Yeah, fake update the position so our anchor calculations take into account. Correct. Good comment. Past self. Then we do the real position update, which is however far that original copy that we held on to, plus however far they were actually able to move without walking into unwalkable terrain. And then we clamp for the edge of the map. Ennis asks, why do we need to make games in Flutter? Well, you don't need to. That's the short answer. I just think it's really fun. And if you, too, think making games is fun, and if you, too, think making anything in Flutter is fun, then I invite you to join us on this journey of making games in Flutter. Because it's really fun. Personally, my brain I was talking with Wolfen about this the other day. My brain really lights up this exact kind of stuff. Programming, the logic, like movement logic of enemies, the attack logic of enemies. I just think that is so fun. I've been a conventional web developer for 12 years before I joined Google and worked on Flutter. Written a lot of forms, a lot of API calls, a lot of JSON parsing, a lot of that stuff, a lot of validation. A lot of those things exist in games as well. But man, there is something about just the fun, whimsical aspect of game development that really just turns my brain on. And that's why we're doing it. But you don't need to. You can do anything. Okay. So what were we doing? Oh, yes, we have this whole bit of movement logic. And I kind of think I want to like break this out into maybe like a list of movement like modules or something that can be passed into different components, and then they'll all use that. They'll all like run through their movement modules in their update method. And this will allow us to have like a wandering. Someone was asking about that. We could have a wandering module that the zombie will get. Of course, the player won't get. Let's do this. So let's make a new folder in lib. Maybe we put it in utilities. I don't know. Sure. Let's put it in here first, and we'll just call it movement.dart. And in that utilities barrel file, we'll export movement.dart. All right. So I think we're going to want an abstract class and then different implementations of it. And they are going to have, they're going to probably take the whole component and they're going to return a vector2 that gets added to its position, or maybe they should just mutate the position itself. I wonder if they're going to need to know about previous components' work so that they can, yeah, this is really interesting. Class, movement module. Thinking on the fly here. Abstract class. So also making an abstract class with a single function, a single method is typically viewed as a silly thing to do. But I feel better passing a class into these components than like passing in a list of functions. If you pass in a list of classes, there's something about that that just feels nicer. So that's what we're doing. And also they may have more functions over time. But for now, let's start with the idea that they return. No, let's start with the idea that they mutate the component. I don't know how long this is going to hold up. So this would mean it's void and apply movement. And they take a position component. Okay, let's try it. So then we'll have a unwalkable terrain movement. I don't know. This isn't a wonderful name for this. And this implements movement module. And then it has this method. And this method does everything that is in player right now. Almost everything. Oh, interesting. No, they're going to need to have potentially different functions. I'm thinking about this already. The unwalkable terrain movement needs to know what you're moving otherwise. So some movement modules might like constrain your movement, and other ones might determine your movement. And this means that I'm going to get less fancy. We're not going to go abstract because I don't yet know how these are going to all relate to each other. So they're just going to be unwalkable terrain movement. And this is going to constrain what is all the data that this is going to need? It needs to constrain movement. So I think we need to pass in the unmodified. Maybe we pass in the original position. Well, let's just do all of these things again. So we want this, and then we want the original position. Original position. And I think this is going to do it. Oh, did I write moment somewhere? Sure did. Thank you. Good eye. All right. So, first of all, and we're going to need to know what the movement was. And we get, yeah, this is going to be a little interesting. So to start, I'm going to grab all this code and move it over. Yeah, so position of anchor. So these are all going to be on the component. Then the game reference, this is also now on the component. It's actually like a has game ref situation. Oh, how do I tell? I don't actually know how to do this. This is interesting. We need to tell the system that this isn't just a regular player component. It's a has game reference version of, or sorry, position component. You know, in theory, they might not all be. I guess we need to pass in the game world. Yeah, they're going to need to pass in the game world. So I'm going to remove that, and we're going to add the game world, and we're going to make all these parameters named because there's starting to be a lot of them. And they'll all be required. And now we need the game world as well. So this is required zombie game. All right, now we need to import unwalkable component and movement this frame. Let's think about that. Coming out of player in update movement, this frame came from movement times speed times delta t. I really want to avoid passing like 6 parameters into this. How can we simplify this? Can we calculate movement this frame in here, in this method? No, because movement this frame might be derived by other classes. Movement this frame isn't necessarily going to come from this. It's not going to be, this is limiting the movement this frame. It is not deciding the movement this frame. Oh, I think that's what move. Oh, no. Movement was the raw vector. Movement this frame is simply normalized, or it's like multiplied by the speed in the delta time. That's fine. So this movement this frame is what we want to pass in. And this will actually work for both of these. Perfect. All right, now for the player, let's actually use this. So the player is going to, there's no state in this class. This basically is just a single method, a single function pointlessly wrapped in a class. Whatever. So I'm going to, do I have utilities imported? Nope. So let's save for ourselves. What's it called? Unwalkable terrain movement. Or like checker is really what it should be called. I am going to rename it to checker. And then this will be check movement. Way better. Okay, so we pass in the component, pass in the whole game world, pass in the movement this frame, and the original position. And I'd like the original position. Oh yeah. We have to apply movement this frame. So this is where we said original position. All right, let's pass in an unmodified component. So we'll say the position there is original still. So component.position.add the movement this frame, which has been constrained to not move on unwalkable terrain. And we don't need to do, oh no, we cannot pass in an original component unmodified, because then the position of anchor won't work. Position of anchor would not work. Yeah. We have to have some concept of the original movement. And I wonder what makes sense. I'd love to avoid a fifth parameter. Oh, no, we already have original position. Oh, I'd still have to have as few parameters as possible. So what we'd have to do right now is like, we just apply our movement like this, and then we'd say movement checker dot check movement. And this would take the component, which is ourselves, and what are the other parameters? The game, which is this dot game. Oh, we don't need this anymore for that. And movement this frame, which is movement this frame. And the original position, which is original position. And that handles that basically also handles this part. We'd say component.position equals position original position.add. Cascade operator. Did any of that make sense? Now down here, we get rid of this, and we could potentially move this whole clamp thing into its own thing as well. Actually, let's call outside of the game world unwalkable terrain. And there it is. So component.position equals component.half-size dot size divided by 2. Max position probably comes from the game world. Where did max position come from? Game world dot size minus half size. Yeah. So we're starting to recalculate some stuff that was cached, and that is something that can be improved upon. Maybe we'll actually make use of this thing being a class. Woo! All right, so the player's movement code, let's revisit. Hold on to the original movement, figure out how far we should have moved this turn, apply that movement, check for any unwalkable terrain, and this will bounce us back if necessary, ever so slightly. And this will also keep us from moving out of the game world. Any fatal issues? No? All right, let's rebuild the app and see if we still can't walk on the house. All right, I still cannot walk on the house. Great. Let's now apply this same thing to the zombie. It's getting exciting now. You could imagine in the future passing, and the future is now. This dot component final position component. Now we don't have to pass in this anymore. And we could start to cache some other stuff. And so we'll instantiate you in the onload method. Unwalkable doodad equals this. Well, that was an interesting clipboard situation. And we pass in ourselves. Nice, that's better. And we get rid of this parameter. That did feel really ugly. Okay, let's do the same with the zombie. So the zombie now gets the same property. And in its onload method, we'll initialize the same movement checker. And in the update method, we'll start to do some of the same stuff. So we had here move along path. So here we already have boop in this frame and the position.add. So I think we just call this. And the original position, we just have to hold on to. Come at me now, zombie. Ha, look, it gets stuck. And it's got an ever so tiny X vector until it catches up. This is kind of fun. Can we get in far enough in front to lock it in? Okay. So we have some very, very, very simple zombie logic here. Ooh, Lucas giving us another in the future idea. Another thing that could be done is to have the checker as a mix-in on the position component or an even tighter interface, and you wouldn't have to pass in so many arguments. I do like that. Yeah, if it was a component, or sorry, if it was a mix-in on the position component, then we would, that is a lot nicer, isn't it? Yeah, we got time. Should we do it? So this will be unwalkable. Oh no, it's a mix-in. And this is on position component. So now you don't have your own thing. You don't have this. Oh, can it be like has game ref as well? Can we do this? It doesn't like it. Can you say, oh, it might not like it for a different reason. Oh, you can put a thing, you can put two classes here. Game stays relevant. Wonderful. Oh, I had some really nasty shadowing going on that was just luckily working. Really, really nasty. Whew. Okay, thank you, Lucas. That's brilliant. So now we go back to the player. And you also have an unwalkable terrain checker. And the movement, the method was check movement. So we'll still call that, but it's just like this. Oh, Lucas, stay my beating heart. Get out. I have been to Paris. I have seen the Mona Lisa. And this is more beautiful. Oh, it's just too good. It's just too nice. That's wonderful. That's good. Okay. Some line that's red. Nope, that's not it. Here we go. Oh yeah, we don't need that anymore. And we don't need this anymore. All right, let's refresh, make sure it still works. Oh, you love to see it. You just love to see it. Wonderful. Okay, now it's time to actually have the zombie maybe do something more than walk straight and get caught. Though this is already pretty satisfying. What I was thinking is that the zombie could detect, okay, I'm crossing a boundary. Like it would calculate that this line is being intersected. And what it would then do is figure out which end of the line is closer to the zombie or maybe closer to the player. I'm not really sure what would make the most sense. and go to that. So it could like go around one corner, but it couldn't. If it was in a horseshoe, it would get stuck still. It would not be able to navigate its way out of a maze. Does that make sense? Let's see how that works. I don't have any horseshoes on the map right now, so we'd have to go back into tiled and do that. But I think, yeah, I think this is going to be good. Let's give it a try. So the zombie has move along path that is now going to get a lot more interesting. So we have our path to player that got passed into move along path. And we're about to see, does this intersect anything? So first, let's say, let's have a new method here called get intersection. Maybe we want both like the line and the intersecting point. Oh, there's some new Dart 3 code for that. So this will be the line, unwalkable boundary, and the point, vector 2, that is the intersection from, I've never actually written a method that returns two things in Dart before. So we'll see if this is even correct. Also, is my pub spec high enough for this? Yeah, I think so. Vector 2 intersection. So this is going to equal, gosh, I can't type. Get unwalkable collision. And we're going to pass that the path to player. Okay, so we need this method. It doesn't exist for just another minute or two. And you're going to return a record. I don't know. I forget if we need like parens around it or something. I don't know what's going on. I don't know how this works. Do you need parens? Oh, that's better. But this is still wrong. Maybe we do this. I think I wrote Python syntax, but maybe we have to do this. Oops. Oh, there we go. That's really awkward line. Oof, don't like any of these. Oh, I don't like any of these. I don't like that either. These aren't good. Could this be better? No, they're just all bad. Okay, whatever. Here's the time to actually do this. So our get unwalkable collision, we are going to iterate through in the world, remember, close some other files. In the world, when we constructed the unwalkable objects, we stored all of their edges on the unwalkable component edges line. So we'll say for final line in game.world.unwalkable component edges, if path to player dot intersection, is that what I called it? Intersection? Intersects at. Yeah. Where is I don't know why I wasn't showing that before. If path to player dot, no, let's call it first. Intersection. So we're going to grab the possible intersection, and this is a nullable vector 2. So if this does not equal null, then and we want the closest one, because you could cross an arbitrary amount of them. We want the closest one. So we're going to add this to a list. This is going to be a list of vector 2 objects. So if the intersection does not equal null, then intersection points dot add the intersection. Now we need the closest intersection. So for that, this means we can actually just make a line and calculate the length. And yeah, we don't need to make a list. This would be so much worse. So what I'm going to do instead is every time we find one, make a line, compare it to the shortest line so far. The line will, of course, be from the zombie to the intersection point. Yep. So this is going to be vector 2, nearest intersection. And then we'll have a double that is the shortest length. Okay. So if nearest intersection, if intersection does not equal null. So we're just saying here, did the line that we just look at intersect? Now we'll say if our nearest intersection is null, then this is our first point. So our nearest intersection is merely the intersection point. Man, I really cannot type. And our shortest length is a line starting at our position, the zombie's position, and going to the intersection point, dot length. Else, we have to check. So we'll grab a new final this length, length to this point. And we'll say if length to this point is less than the shortest length, then, and the shortest length we know is not null because it became not null in sync with nearest intersection. So then shortest length becomes this. And our nearest intersection, we grab this line. And that means at the end of this method, and we need to save the line as well. Line, so this would be the unwalkable boundary itself. Okay. So now at the end of all this, get unwalkable collision, we return, and I quote, the get out of here tooltip, the unwalkable boundary, and the nearest intersection. What do we think the odds are that that works? In these situations, it's pretty good to use length 2 since you don't have to do square root under the hood. Oh, okay. I am unfamiliar with that. What's length 2? I'm unfamiliar with. Oh, it was on the vector 2. So you're telling me. So what's the difference? What does length 2 do? Is it like less precise? If you look at your length implementation, you just remove the square root part. Oh, I see. That makes sense. What's the problem with this? Num. Do we have to just do 2 double on both of these? Does this look right? Yeah, in a new implementation, right? Otherwise, suddenly our lines are all really long. That's super funny. Okay, length 2, love that. Length 2. Man, people are clever. You game devs. Let me tell you what. Very clever. Da, da, da. Okay. So now we have our unwalkable boundary that we hit and the intersection. And from here, we're going to say if unwalkable, let's just say whatever. These are going to be null or not together. So if intersection does not equal null, then wait, what are you mad about? What does this say? Operand can't be null, so the condition is always true. Did I outsmart myself with this? No. Oh, it's the whole tuple. Oh, so we can call, I forgot about that. So this is like collision, and we'd say collision dot star one, I think, because 0 also exists. No, 0 doesn't exist. So it's star. I mean, I'm saying star typing, not a star. $2. So this is the second index. So this would be the actual point. Oh, this should be a nullable thing with not nullable parameters. Yeah, that's so much better. Look at me. I'm learning how to code. So we'll say return if this does not equal null, then we return these. Oh, we don't. It doesn't need that, but it probably needs it here. Otherwise, we return null. Okay. All right. Look at me now, ma. All right, so now it's if collision does not equal null. Oh, this is so much better. This is so much better. Oh, based, welcome. But I don't use the Dracula theme. This is Synthwave 84. Different in subtle but existing, but non-zero ways. Yeah, Lucas, for anyone who's not aware, square root is quite computationally expensive. Best to not do it repeatedly every frame for potentially many zombies. Yeah, huge optimization there. So if our collision does not equal null, then it's time to do something different. So let's go back and look at the game world. Whoa, we're being stalked. So right now, we would need to find the end of the line that is closer to the zombie. Right? And then we reset our path to basically go to there. Let's see what happens. So if collision doesn't equal null, we don't need the colliding point even. We just want the line. We don't care about the middle of it. Yeah. This was a fun stroll down Dart 3 lane, but we actually just need the line, which will be nullable. Oh, it was fun. It really was. So now we just return the unwalkable boundary, which is nullable. Oh. Okay, so in the collision, now instead of calling it a collision, we'll call it the unwalkable boundary. Whoa, what did I just do? Oh, I highlighted this one and this one, and I thought I was going to get the one below. Whatever. We'll leave it as collision. So if collision does not equal null, then we need the distance to both the start and the end. So let's take the min. We're going to have to import math. Okay. Very exciting. So let's take the min Oh, getting the min distance wouldn't tell us which point it was. All right, get out of here, Dart.math. Oh, I wonder if we're still going to use it. I don't know. We'll see. So let's get the distance to the start and the end. Equals a line where the position starts with the zombie's position and it ends with the collision dot start, because collision is really a line. It's a poorly named variable. And then we'll do length 2. And then we'll distance to end. And now we want the minimum of those. So if distance to start is less than distance to end, then our new path to player, get a load of this. I really think it's going to get stuck at the corner or something really annoying. Oh, maybe we can go just past it or something. Oh, that's interesting. So our new path to player is going to be a line that starts at our position and it ends at the... So start is closer. So this would be collision dot start. I wonder if it might get stuck. You know what this could have been? We could have said, no, we're just leaving it at this. All right, so we've updated our path to player. Let's see what the zombie does. Let's see what the zombie does. Crash the game. Wunderbar. What? Line 38. That's right here. Did I return the wrong thing? Unwalkable boundary. No. You return a line. I think I changed too much stuff. Probably not. There's probably an actual error. Let's continue to look at this. The linter doesn't think there's an error, and it's rarely wrong. So path to player. Path to player is a line. Yeah, seems good. Seems good. Hey, you're learning Flutter at college. Heck yeah. I'm learning Flutter too. As we can see by all of the errors. Okay. Line to vector 2. So this is a function, is not a subtype of just a vector 2 on line 38. Am I like not calling the method or something? I am calling the method. What is it talking about? Does anyone have any idea what it is talking about? This comes from line 32, which is exactly what we expected. And then we call get unwalkable collision, and it says that the type of a function that takes a line and returns a nullable vector 2 is not a subtype of a vector 2. Yeah, I know. We're calling the method. I'm not assigning the method to the variable. What is this? Does anyone see the issue? Am I assigning this method to this value? was thrown during a scheduler callback. Some type of, wait, vector 2. Some type of vector. This says line. It doesn't say vector 2. Line path to player. Oh, and then it goes to line 64. There's an error on line 64. Ah, here I am actually assigning a method to a thing. Okay. So our zombie's getting stuck at corners exactly as I feared it would. Okay, so go down a little bit. Nope. It's going to the closest corner to it, which can be further from the player. So that logic is very silly. Let's fix that real quick. We don't want we want the player's position. So this is game.world.player. Okay. Run it again. Here we go. Tracking the player now. And it's getting stuck at the corner. So it needs to get around the corner. The player kind of has to help it get around the corner. It's like, come on, you can catch me. You can do it. I swear. So we need to make the line a little longer, is kind of what I think. But the thing is, whoa, how did you get over there? Just because I switched tabs. That was some. Oh, Lucas, I've been wondering about this. Is there. Okay, this is super interesting. Let's get on the other side. Let's lose the zombie. Okay, so now it's stuck, right? It goes to the corner and gets stuck, but that's its own problem. Now when I tab away, the DT builds like crazy. Then I switch back and the zombie has moved. I think something like that is what's happening. And I've been wondering, does Flame have a way to, like, is there a pause mechanism to know when the game clock should actually be stopped and have Flame handle, like, not incrementing the delta time that it's going to pass to the next update cycle? I don't know if Lucas or Wolfen are still here. We've been doing this for a while, but this is an open question in my mind. Anyway, let's try to make these zombies a little smarter so they can get around this corner. This is really interesting. Oh man, it keeps happening. Think about what we need to do. So it's stuck on this corner because the line to it points to, if I zoom in, do you guys see it? If I do like this, oh yeah, I think it's working. I can't really tell. I don't know if you're seeing more or not. Someone say in the chat whether or not the game just got bigger on the stream. And now did it get smaller again? Oh, in the next release, that's included. Very nice. I know that there's some life cycle, some like desktop life cycle stuff that's coming to the Flutter engine right now. And that could presumably help for tabbing away and whatnot. Oh man, a link to the PR incoming. Well, sometimes YouTube doesn't like people to post links. And it seems like you may have been bitten by that. But that's awesome. All right, let's think about, just got a couple minutes here. I'd like to wrap up soon. How are we going to get this zombie to go around the corner? I'm going to give it a movement vector that is a little longer. We're just going to make it longer. And that should do something. I don't know if it's going to really work, but let's find out. So I'm going to add a method to line that will be extend. Oh, extend is going to bust. We'll have to, this will be like a copy with thing. Yeah. Multiplier. Oh, line 2. That's not what I meant. So we need our vector 2, and then we would need a new end for that, right? Oh no, our vector 2, we would lengthen, and then that would be its end, but then like plus. Oh, yeah, I've seen this, and it's so dirty I can't even do it. You can also get around what we're talking about by overriding update and throwing away the update if the DT is too big. I mean, maybe it's not that dirty. I don't actually care how dirty it is, but I fear that it's really like edge case prone. I'm curious if my intuition is right there, or if it actually just kind of works fine. But you also have to do it in every component, and that's the dirtiness that feels really stinky. All right, this extend method is going to actually be a little complicated because we need to take our vector and make it longer. So our vector 2 times, can you multiply vectors by a value? Okay, so this is the longer vector. And then we return a line which has the same start that we have. Do you take positional parameters? Okay, that's pretty good. And then the end is the end of that vector 2 plus the start of this line, because that vector is normalized for the position of this line. So longer vector dot well, it's just longer vector plus start. I don't really know. I think I didn't use the multiplier. I love when I do that. Think about what value I'm going to pass in, and then don't use the parameter, and just use that value in the code. Super fun to debug those later on. All right, so it is. Oh, it did get around the corner. It got around the corner really slowly, so it's really imperfect. But it got around the corner. All right, so let's watch it get her. Oh, all right, and it's still getting stuck. It's really, really derpy. Actually, I think it's still too derpy for a good zombie. And it got stuck again. Oh, come on. Figure it out, dude. All right. That's where we'll call it for today. Lucas says this is going back to capturing when the game has been frozen for a while and the delta time is artificially large. You only have to throw away large delta times. Do it in update tree in the game class. Okay, that's really nice. So you don't have to do it in every component. And how different is your implementation coming in the PR that YouTube wouldn't let you link? Does it have, are you hooking into the game engine lifecycle things to just know when a user tabs away and the app loses focus? Or are you doing something else? Or are you just throwing away large values? The other dirty thing to it is like, what is your threshold there? If the game drops a couple frames, you could have 30 milliseconds, you could have 60 milliseconds. You get way above that 16 millisecond budget of 60 frames per second. Oh, nice. It's going to hook into the life cycle, so it does it properly. Very cool. All right. Folks, the zombie is partially pathfinding. It's finding a really imprecise path It can kind of get around corners sometimes, but it also gets stuck. Oh, it eventually got around that corner. I would call this imperfect. Oh, here it's just stuck again. Oh, I gave it a little help and it got unstuck. See, that really made sense. This is imperfect, but it's not bad. The zombie is following us around, being a real annoying pest. And in the future, maybe we'll optimize this a little bit, and maybe we'll get it. We'll get it. More of them spawning. Worry about health bars. Worry about how the player fights back. Worry about zombies that wander when there is no player. Stuff like that. Yeah, I think that'll all be pretty fun. But that will do it for today. I don't know what next week will entail. We'll all have to wait and find out together. But folks, I have had a pretty good time today making these zombies follow me around the riveting game world that we're building. And I hope you enjoyed as well and maybe learned something. Have a great rest of your day, weekend, and I'll see you next week on Observable Flutter.